Hey everybody, let's get even more practice trying to figure out which method to use when, node voltage or mesh current. And generally, you're trying to keep an eye out for supernodes, supermeshes, or if one of the unknowns is easy to solve for. Okay, so let's give this one a try. So let's say we try out the node voltage method. So where are the essential nodes? Okay, we got these four. And now you take a look. Are there any supernodes? Yes. We have this one. Let me label them. So let's say okay, so we have these four essential nodes, and there's a supernode between B and C. So I don't want to pick node B or C as my reference. So I'm going to either pick my reference at A or D. So how about at D? Okay, so I can write two node voltage equations. One at A, so KCL at A, VA over 5 plus, let's go this way now, VA minus VB over 4, and now let's go this way, VA minus VC over 20. Okay, now let's do KCL at the supernode. So let's start over here, VB over 1, now let's go over here, VB minus VA over 4, and over here now, VC minus VA over 20, and then last over here, plus 20. Okay, so we got two equations, three unknowns. Now we need the relationship between VB and VC. So which is more? Just look for, right, this is the plus sign over here. So definitely this side of the voltage source is more. VB is more than VC. By how much? This much. Okay, now we just need an expression for this current, which is right here. So if you look at this resistor, right, this side is 0, this side is VB, so what's the current? 0 minus VB over 1 ohm. And there we go, right? You just substitute that right here. Now you have three equations, three unknowns. I mean, you have four equations, four unknowns, but you put this there and then you're left with three. Okay, now say we want to try the mesh current method. So we got three meshes. So let's say we go this way. Okay, I'll label them. And what I was trying to point out earlier was, look, mesh current IA is 20 amps. That was easy. So really we just have two more mesh currents to solve. So let's go with mesh B. I'll start over here and then I'll go clockwise. So here, 1 ohm IB, over here, 4 IB minus IC. Now we're over here, 5 IB minus IA. All right, now let's go mesh C. Let me start right here and I'll go clockwise. So starting here, 20 IC minus IA. Over here now, 4 IC minus IB. Over here, plus this voltage, 6.5 I delta. And then that's it. And now we just need an expression for this current, which is right there. So here, for the mesh current method, there we go. Three equations, three unknowns, as opposed to the node voltage method, four equations, four unknowns. Okay, so for this particular problem, the mesh current method was arguably easier because, like right here, is one of the things that kind of caught my eye. All right, let's try another problem. Okay, here we go. Already, it kind of stands out to me like I got that current source. So if I do a mesh current like this, it's kind of the similar situation. So maybe let's start there. How about call this A, B, C. So already we got mesh current IA, 5 amps. That was easy. So now let's say mesh B, let me start here and I'll go clockwise. So 5, now we're over here going clockwise, 38, IB minus IA, over here, IB minus IC, now we're over here, 12 IB. Right, now let's go mesh C, let me start right here and go clockwise, so over here, 30, IC minus IB, over here going clockwise, 6 IC minus IA, over here going clockwise, plus 67, and over here, 40 IC. Okay, so, right, there are 3 mesh currents. We solved one immediately, so 2 equations, 2 unknowns. Right, if we did the node voltage method, where are the essential nodes? Here, 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 here. Okay, any super nodes? Nope. All right, so let's say I'll pick one as a reference, and then I'll label these. All right, so already the node voltage method is going to be 3 unknowns. So right off the bat, I know that's more than 2 equations, 2 unknowns. But if you were to do it, let's starting at KCL at node A, let's go this way. Let's see. We need the current going this way, right? So what is the voltage right here? Is it more or less than here? So if you look at the plus sign, this voltage is more than it is here. How much more? 5 volts. So the voltage right here is actually VA plus 5. And then that means for KCL at node A, the current here is this voltage minus this voltage over 12. VA plus 5 over 12 is the current here. Another way to interpret that is, see how these two are in series? It's also the same as this, if I were to, right, between node A and then the reference, if I just exchange them, they're in series, then what's the current here? This voltage minus this voltage over 12. This is VA. What's the voltage here? More or less than here? Let's see the plus sign. It's less on this side. How much less? 5 volts. So the voltage across here would be VA minus whatever it is here divided by 12, and the voltage here is negative 5. Negative 5, right? So see how it's the same? Okay, so back to node A, KCL going this way, VA minus VB over 38, and then over here, plus 5. Okay, node B, let's go this way, VB minus VA over 38, let's go this way, VB over 30, and then this way, VB minus VC over 6. Alright, now node C, KCL, so let's go over here, minus 5, over here, VC minus VB over 6, and then over here, similar situation, we need the current this way. Okay, so what's the voltage here? More or less than here? Less. How much less? This much. So the voltage here is VC minus 67. the voltage here is 0. That's our reference. So what's the current going through this resistor? VC minus 67, that's over here, minus 0, which is over here, divided by 40. Okay. And there we go. That's 3 equations, 3 unknowns using the node voltage method. Okay, last one more example. Okay, now let's take a look here. If we did the node voltage method, how many essential nodes? Here, 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 4. And are there any supernodes? Nope. Okay, so we pick a reference. I'll just pick one over here. And let me label these. Okay, so then let's do KCL at node A. So let's go this way. And then what's the voltage here? More or less than here? Less. How much less? 200 volts less. So the voltage right here is VA minus 200. So then what's the current this way for the 10 ohm resistor? It is this minus this over 10. VA minus 200 minus 0 over 10. Okay, so that's KCL for node A going this way. Now let's go up. VA minus VB over 10. Now let's go this way. VA minus VC over 25. Right, node B, let's go this way. VB minus VA over 10. This way. The current is in, so minus how much? This much. 4.3 ID, and this way. VB minus 0 over 100. Okay, and then node C, let's go up 4.3 ID. It's KCL, right? So the current here, VC minus VA over 25, and the current here, VC over 50. Now we just need an expression for this current, and if you look right here, that current is VA minus VC over 25. So here we go, node voltage method, 4 equations, 4 unknowns. I mean, you just take this and put it right here, and then now we're down to 3 equations, 3 unknowns. Okay, now let's say you wanted to use the mesh current method. So let me draw some mesh currents. So let's say, okay, let's draw one over here, here, here. Okay, is there any that it's solved immediately? Not for this circuit. Although I do notice that we have a super mesh right here. Okay, so when we do KVL, there's mesh A and the super mesh. Okay, so let me write those out. So for mesh A, let me start right here. So KVL, so minus 200, going over here clockwise, 25, IA minus IB. Okay, let's keep going clockwise. So right here, 50, IA minus IC, and then over here, plus 10, IA. Okay, so that's mesh A. Now KVL for the super mesh. Let me start right here, and then I'll go clockwise. So over here, 10 IB. Right, so we're going clockwise, so now we're over here. 100 IC. Let's keep going clockwise around the super mesh, so we're here now. 50 IC minus IA. And then over here, 25 IB minus IA. And we started here, right? Okay, so that's it. Now we just, let's see, 1, 2, 3 unknowns, 2 equations. So now we just need to relate, let me draw, see the dependent source, and then there's mesh current IB here, I'm talking about right here. IB is on the left side, and then IC is on the right side. So which one is more? If you look at this arrow, IC is more. How much more? This much more. 4.3 ID. So there we go. 1, 2, 3 equations, 3 unknowns for the mesh current method compared to 4 equations, 4 unknowns for the node voltage method. So this one favored mesh current. Okay, so hopefully you're starting to get a feel for which method works when. So just keep on practicing. That's the ticket. And if you have questions, let me know. Other than that, I'll see you on the next video.